How we doing, everybody? Mr. Dickin here, and in this video we're going to be talking about basic properties of exponents. Now, properties of exponents, there's a few different scenarios we're going to have, and I'm going to highly advise you pause the video here so you can either jot these down or print this out or take a picture, what have you. Properties of exponents will come into play pretty frequently as we go through and learn how to simplify expressions. So I'm just quickly going to go through kind of how and why some of these things work. So the first property we have is going to be the product rule. And that means if you have two exponential expressions with the same base, in this case it's b, being multiplied together. So you see that b, that base, written twice, you would add the exponents together. Now the reason why that works is, let's say I had b to the second times b to the third. Well, that means I'd have 2b's times 3 more b's. Well, all total, I would have 5 b's together. So I'm essentially adding those. Similarly, when we when we divide exponential expressions, again with the same base, we're going to subtract, find the difference of those exponents. So if multiplication pairs up with addition, division pairs up with subtraction. The reason for that, I'll use the same 2 and 3 values. If I say had b to the third over b to the second, well, I would need to subtract these. So I should get b to the first. But the reason why that works is if I wrote this in expanded form, I'd have 3 b's up top, 2 down below, and I cancel. I'm left with b to the first in the numerator. Now let's say hypothetically if those things were flip-flopped, and we had the b squared up top, so b to the second over b to the third, and we subtracted, that would give me b to the negative first. And we're going to learn here in just a second. We typically don't like to have negative exponents, so anytime you have a negative, to make it a positive, you switch its position across a fraction line. All right, next up, power on a power. So if you have the base written once and only once, and there's an exponent directly touching the outside of parentheses, that will multiply inside the parentheses to the exponent. So if this was b to the second raised to the third power, that would give me b to the sixth. The reason why is if I were to write b to the second 3 times, so b squared, b squared, b squared, I'd have 6 b's all total. This next property is kind of one step further. If you have an exponent directly on the outside of parentheses and there's multiple pieces inside the parentheses being multiplied together, so this only works if things are being multiplied. If there's any sort of plus or minus action in here, we can't do this. The exponent on the outside will multiply to every exponent on the inside. General rule of thumb, if you see something without an exponent, go ahead and put a 1 on there, just as a nice reminder to yourself. Same goes for division, or if you have a fraction. If there's an exponent directly on the outside of parentheses, that's going to multiply to every single term inside parentheses, assuming we are only doing multiplying or dividing. Again, if you see a plus sign or a minus sign in here, that is ruined. All right, next, 0 exponent. Anytime you have something to the 0 power, that just becomes a 1. Anything to the 0 power is just 1. Now that's going to be important to remember because we're going to use that to kind of simplify some problems a little bit quicker. Because as soon as I see anything to the 0 power, I just kind of ignore it, right? Multiplying by 1 changes nothing. Dividing by 1 changes nothing. So anything to the 0 power, I'm not going to say it cancels away, but it can kind of become negligible. And as we discussed earlier, anytime you have a negative exponent, it's going to switch spots across the fraction line. So technically speaking, this is b to the negative x over 1. To make that a positive, it has to drop to the other side of that fraction line. One other pattern that you could use for this is if I have, say, 3/4 to the negative second power, I could flip that and say 4/3 to the positive second power. That's another property here with negative exponents that we can use. All right, so now let's go ahead and get simplifying. All right, first one, number 1. I need to simplify this expression. plain old numbers will multiply with other plain old numbers. So here I've got negative 7 times negative 2. That is a positive 14. I have x, oops, let me change colors here. I have x, that'd be x to the first, by the way, times x to the fifth. So x to the first times x to the fifth. Well, that's going to give me x to the power of 6, x to the sixth power. And then if I have y to the fourth, that's only going to interact with this y to the sixth. So I have y4, I've got y6. Using my properties, I'd add those exponents to get y to the 10th. And that is now simplified. Number 2. Got negative 3, x to the fourth, y to the fifth. First thing I want to do is, if I ever see something without an exponent, I'm going to go ahead and tack a 1. That includes the plain old number coefficients in front of things. Now this exponent on the outside will multiply to every exponent inside. So now I'm going to have negative 3 to the third power. I'm going to have x to the 12th power and y to the 15th power. Negative 3 to the third power, that's negative 3 times negative 3 times negative 3. That's going to give me a negative 27. So negative 27, x to the 12th, y to the 15th. Number 3, there are 2 ways you can do this. All right, so I'm going to do each way, and I'll let you kind of choose which one you like better. Which one do you like better? Method number 1, we can go through, pretend there's a 1 on that 4 and a 1 on the y there, and we can distribute this exponent of negative 3 to everything inside. Okay, so that would be 4 to the negative third, x to the negative sixth, all over y to the negative third. Now, I'm not too thrilled about anything with a negative exponent. If there's a negative exponent, in order to become positive, it has to switch to the other side of that fraction line. So this 4 to the negative third is actually going to be thrown to the bottom in order to become positive. This x to the negative 6 is also going to have to go to the bottom in order to become positive. Down below, I've got y to the negative third. Well, I want that positive, so that switches sides across that fraction line. So it'll be y to the third. And now we just need to simplify. What is 4 to the third power? 4 times 4 times 4. Well, 4 times 4 is 16. 16 times 4 is 64. So we have y to the third over 64 x to the sixth. That's one way to do it. The other way is we can start off and say, hey, you know what? I'm not really thrilled about this negative exponent, so I'm going to get rid of that first. And in order to do that, to make it a positive 3, I just flip the insides out. So I'm going to essentially do the reciprocal. And now from here, we'd get y to the third, 4 to the third, x to the sixth, and we'd simplify again. So essentially, you have the choice. Do you want to tackle the negative exponent first and get that out of the way? Or do you want to move things around at the end? The order in which you do those does not matter. All right, number 4 here. Number 4 might look scary, but I promise you it's not. We have negative 35 x squared y to the fourth all over 5 x to the sixth y to the negative eighth. Just like before, I'm going to kind of color code these. Plain old numbers, so basic coefficients, will only interact with other basic coefficients. So in this case, I've got negative 35 over 5. If I think of that as a fraction, that would reduce down to negative 7 over 1. And no, you don't need to write a 1 in the bottom. Next, I have x squared up top and x to the sixth down below. X's will only interact with other x's here. If I were to write this out in expanded form, I have 2 x's up top and 6 x's down below. So if I were to write this in expanded form, that's what it would look like. Now if I cancel away some x's here, looks like I'm going to have 4 x's remaining in the bottom. We could also use our property of exponents and just say, all right, 2 minus 6 is negative 4. And the fact that it was a negative 4 means it's going to have to flip down to the bottom. So that's another way to think of that as well. Then we have y to the negative 8th power. Well, again, anytime you have a negative exponent, that has to flip up to the top. So I'm going to imagine there's a y to the 8th up here instead of y to the negative 8th down below. So now when we do that, we'd have y to the 4th, y to the 8th. That gives us y to the 12th in the numerator there. All right, we're cooking along. Number 5. Negative 30, a to the 14th, b to the 8th, all over 10, a to the 17th, b to the negative 2nd. So again, with this, there are two ways to do it. One, you could bring in that exponent from the outside to everything first. But if I'm looking ahead, I don't know what 30 to the 3rd power is, and to be honest with you, I'd rather not find out. So what I'm going to do instead is I'm going to actually simplify the stuff inside, and I would suggest doing that as well. Simplify the stuff inside first, and then work with that exponent on the outside. So if I simplify the exponent or the inside of this first, I'm going to kind of think of this in almost like a color-coded manner. Again, negative 30 over 10 would be negative 3 over 1. If I look at my A's, I've got 14 A's up top, 17 A's down below. If I were to cancel things away, I'd have 3 A's remaining, and those 3 A's would be in the bottom. Or you could do 14 minus 17 to get negative 3. Negative means it goes down below. And then we'll go to the B's. Again, I'm seeing this B has a negative exponent, which means that has to move up to the top. So I already have a B8 up top, and I throw a B squared up top. That'll give me B to the 10th power. So now the inside has been simplified. Each letter appears once and only once. It's what we want. So now this exponent will go in and affect every single exponent inside. Negative 3 to the 1 times 3 power. So negative 3 to the 3rd power is going to give me a negative 27. B to the 10th times 3, so that would be B to the 30th. Down below, that would be 1 to the 3rd power. Well, 1 to any power is still just 1. So I could write the 1 there, I don't have to. Then we'd have a to the 9th. All right, one more. We have 4 a to the negative 5th, b to the 3rd, all over 12 a to the 3rd, b to the negative 5th, all raised to the power of 0. Well, I kind of foreshadowed this. We have an exponent of 0. This whole thing is just going to be 1. Anytime you have something raised to 0, the entire base just turns into a 1. So you could go through and try to do all the properties there, but let's be honest, you're just going to waste your time if you do that. All right, excuse me. This next chunk of problems, I'm going to have you attempt on your own for extra practice. So if you don't have these written down or if you don't have the PDF, go ahead and write these down and then check your work against the completed notes file that's been provided to you on Classroom. In the interest of time, we are going to transition over to problems with rational exponents. Rational exponents. Good old fractions, everyone's favorite. So the properties are still going to be the same, but now we have to deal with fractions. Now the big thing when adding or subtracting fractions, you have to have common denominators. Whenever you are adding or subtracting fractions, you're going to need to have common denominators. Okay, so here we're going to have 2 times 5 is 10. Then x to the power of, let's see, if I have 4 thirds, I'm adding that to 8 thirds. Hey, they already have the same denominator. That's awesome. So that'd be 12 thirds. So I add the numerator straight across. Well, 12 thirds, that's just 4. So this would be 10x to the 4th. So again, I just simplified 12 over 3. 12 divided by 3 is 4. Not too terrible. Problem number 2. We have 32 over 16. So let's simplify that right out the gate. That's going to be a 2 over 1 if I reduce that. And then for the x's, let's see, I've got 5/3, and I'm subtracting 3/4. Now these clearly don't have the same denominator, so I have to do some work here. Let's see, I could turn both denominators into a 12. So in order to do that, I'd need to multiply that first fraction top and bottom by 4. So that would be 20/12. The second one, I'd multiply top and bottom by 3, so I want that common denominator of 12. That would be 9/12. Subtract those, and we get 11/12. And it's positive, so it's going to go in the numerator. X to the 11/12 power. Number 3. We'll multiply the plain old numbers. 5 times 7 is 35. Then we have x raised to the power of, well, I need 1/2 plus, I'm adding here 3/4. Well, I can change 1/2 to 2/4 if I kind of unreduce it. So now I'm getting common denominators here, right? 2 plus 3 is going to be 5, so x to the power of 5/4. Getting in the home stretch here, folks. We've got 20x to the 4th over 5x to the 3/2. So first, let's start off by simplifying our fraction. So 20 over 5 is going to be 4 over 1. And now we need to subtract these exponents. So 4 minus 3/2. Again, we need common denominators, so I'll pretend this 4 is really a 4 over 1. Well, I can consider that to be 8/2 minus 3/2. That's going to give me 5/2 as a final. So I'd have 4x to the power of 5/2. And no, you don't need that 1 down there if you don't want to write it. All right, number 5. We have x to the 4/5 power raised to the 3/2. So my base is x, and I need to figure out what is 4/5 times 3/2. Well, fortunately, multiplying fractions is much easier. You just multiply straight across. 4 times 3 is 12. 5 times 2 is 10, so 12 over 10. And that, of course, can reduce down to 6/5. So I'd have x to the power of 6/5. And we'll learn more what those fraction exponents mean here in a little bit. All right, last one we're going to do together. We have 3 to the y/4, or 3y to the 1/4 to the 3rd, all over y to the 12th. So first things first, let's bring that exponent of 3 inside. So I'd have 3 to the 3rd, y to the 3/4, all over y to the 1/12. Well, I know 3 to the 3rd is 27. And then I need to figure out, well, what is 3/4 minus 1/12? Again, we want common denominators here, so 3/4 is really 9/12 minus 1/12. Well, that would be y to the 8/12 power. But we can simplify 8 over 12. That is 2/3. All right, just like before, some problems for you guys to try on your own. Again, if you need to pause the video here to get these written down in your notes, by all means, go for it. The completed work is available to you on Google Classroom, so if you want to reference that, you're more than welcome to do so. You know the drill. If you have any questions, do not hesitate to ask. And as always, folks, good luck, have fun, be safe, roll tide.